Welcome to the session on moments, centers of mass. The objectives for this session are to solve problems involving non-uniform rods. Recall that the clockwise moment of F about the point P equals mod F times d, where the distance is perpendicular to the direction of the force. When the perpendicular distance is not given, we need to calculate it using trigonometry. And in this case, the clockwise moment of F about P, as shown in the diagram, equals mod F times d sine theta. The center of mass of a uniform rod is always at the midpoint of the rod, as shown in the diagram. The center of mass of a non-uniform rod is not necessarily at the midpoint of the rod. So it could be here, for example, as shown. Let's take a look at an example. A bucket of paint and a box of tools are placed on a non-uniform plank AB with length 8 meters and mass 15 kilograms. The plank has a pivot at M, the midpoint of AB. The center of mass of AB is at the point C, where AC is 3 meters. The box of tools has mass 25 kilograms and the bucket of paint has mass 15 kilograms and is placed at A. Where must the box of tools be placed for the plank to be horizontal? So here's our rod AB and the midpoint M as shown. The bucket of paint is placed at A as shown, and the box of tools are placed somewhere on this non-uniform plank AB. The length of the plank AB is 8 meters, as shown here. And since M is at the midpoint, the length MB is 4 meters. The center of mass of AB is at the point C, where AC is 3 meters, as shown here. Now, since force equals mass times acceleration, and the mass of the plank is 15 kilograms and the acceleration due to gravity is given by g, we have that the force is equal to 15 g newtons, as shown in the diagram. We also have that the distance cm is 1 meter. The box of tools has mass 25 kg, so we have that the force acting at the point where the box of tools is placed is 25 g newtons. Again, this is because force equals mass times acceleration, and the mass of the box of tools is 25 kg, and the acceleration due to gravity is given by g. Therefore, we have that the force equals 25 g newtons. The bucket of paint has mass 15 kg. Therefore, the force acting at the point A, where the the bucket of paint is placed, is equal to 15 g newtons. Again, this is because force equals mass times acceleration. In other words, the mass of the bucket of paint, which is equal to 15 kilograms, times by g, the force of gravity, to give 15 g newtons. Suppose that the length A to the place where the box of tools is placed is x meters. We're going to find where the box of tools must be placed for the plank to be horizontal. So taking moments about M, we have, with the anti-clockwise moments, 15 G newtons times 1 plus 15 G newtons times 3 plus 1, the distance from M to A, as shown in the diagram. And this equals 25G times x minus 4. Tidying up gives us this equation, and solving for x then gives us x equals 7, as shown. So the box of tools should be placed 7 meters from end A, or 1 meter from end B. This brings us to the end of this session. If you have understood its contents, you should be able to solve problems involving non-uniform rods. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.